to 30 minutes, but you could change that. For H2O, I would do the same. I wouldn't really change the delta H2O or the reference change, but I might change the time as I got to know my plant a little bit better. Yeah, these are set up for survey measurements. The criteria for when to match and how to match are different if you're using response curves, and we will do that when we do a response curve a little bit later today. We will talk about how we change the CO2. Pardon, frog in my throat. I have no idea if that translates. Yeah, this is for survey measurements. For response curves, we will have different match criteria, and we'll talk about those. But that was a very good question, because, you know, why do we choose these? We choose these for a survey measurement because they give us a good balance between not matching when we don't need to and matching when we do need to. It's funny that you say that, Almaz, because we were just talking about how we would like 15 minutes for a tea break. So we're going to do that. We're going to take a 15-minute tea break, and when we get back, we will start lecturing again.
እስራኤል ግን ባዘጋው አንዴ ጥያቄ አለኝ እና ስንመለስ እንዲመለስልን እዚህ ማቺንግ ኦፕሽን ላይ አሁን ኔቨር ማች ኦልዌይስ ማች ኤንድ ኦንሊ ማች የሚሉ ሶስቱ ኦፕሽኖች ስለዚህ ሪፈረንሱ እና ሳምፕሉ ኔቨር ማች እናደርግበት እንዴት ነው ኦልዌይስ ማች እናደርግበት ምን ሲሆን ነው and only match if የሚሆነው ምን ሲሆን ነው የሚለውን ነገርም አብራችሁ እስኪ እንድትሉልን አልገባኝም እስካሁን
okay
yeah ስንመለስ
you could do after the break
yeah
because I think some of them already okay we'll do it after the break
bye. ገብቷል ሶሪ ጊዜያችሁን የበላንባችሁ እንግዲህ ካፌዎች ልንወጣ ነው እያሉ ስለነበር ነው በጣም ይቅርታ
yeah we're getting ready to start back up is everybody back
yes
okay
so the next thing that we are going to do is we are going to talk a little bit about some of the environmental parameters and the theory and some things to keep in mind when we do survey measurements. So I'm going to share my screen. We will. And then I'm going to do slideshow, play from start. Okay, so the next thing we're going to do is we are going to talk about how we optimize the instrument configuration for an experiment. And we're going to talk about both the survey measurements and we're going to talk about response curves. And in the middle of this discussion, we're going to take a little pause and we're going to get our plant ready to do a response curve so that while we're talking about the types of response curves, and we can have our plant getting acclimated to do that. So the main thing that we have to keep in mind when we are talking about optimizing our instrument for our experiment is how can gas exchange and fluorescence help me answer my question? That's the important part. You know, that's why we How can it do it? Well, we have two types of measurements. We have response curves, which are the response to imposed environmental conditions, and we have survey measurements, which are just a picture under ambient conditions. And yesterday and today, we talked a little bit about survey measurements, and now we're going to start talking about response curves as well. But first, let's talk about survey measurements. When we think about survey measurements, we need to think about the difference between the measured parameters and the calculated parameters. And you saw this slide in my theory lecture, but it's coming back because as we noticed from our looking at the data today, when we had changes in survey measurements or in measured parameters, they really affected the calculated parameters. And we looked at H2O, relative humidity, and light level. So those things really affect how the measurement works. From those measured parameters, our computed parameters, assimilation rate, transpiration rates, stomatal conductance, intercellular CO2, and then so when we talked about your data that you took today, we talked and we looked at the measured parameters to help us understand the computer. That is an important relationship because what we do in terms of setting up the instrument configuration is we try to set up the measured parameters so that the computed parameters are what we want them to be. So let's go through the different environmental parameters and talk about how we set them and why. The ones that we use for survey measurements are light, CO2, H2O, temperature, flow rate. There's also fan, but that's not something we typically change. Shannon did talk about when a plant is sensitive to wind, we might change fan. Typically, we don't change that one very much. And then fluorescence is optional, but fluorescence parameters can also affect the data that we get. If we have a fluorescence parameter that is not set quite right for the flash or the measurement intensity, we can end up with different values than we had hoped for. So the most important one for survey measurements is light, because as Shannon talked about, a plant responds to light differently. And so if we increase the light level, it takes a long time for a plant to get used to that new light level. It's much more able to deal with a decrease in light level, but then when you increase it again, we get into the same problem where it takes a long time for the plant to acclimate to the new higher light level. This is actually an area of research in the plant physiology community because we know that when the clouds go over the sun and the light level in a field drops a lot, then the plant immediately shuts down photosynthesis to some degree. And then when the sun comes back from behind the cloud, it takes a long time to get going again, to get to the same level. And that long period of time is a reduction in photosynthetic response that may be affecting yield. And so specifically, what some researchers are looking at is how they can speed up the plant's response to increased light so that we can have a higher yield. So we have more assimilation faster and we have higher yield because, as we all know, the world's population is increasing and we need more food. So especially crop plants, if they could be more effective in using their light, then we might be able to get better yield out of them. But what this all means for you when you choose a survey measurement is that we want to choose a light level that is similar but not much higher than the light level that our plant is already used to. The other thing that we need to think about is the sun. But if our sensor is flat to the sun, so the sun is up here and our sensor is here, then we assume that this is one level of light. But if the leaf is actually tilted, but the sun is here, it's a different level of light. So when we set our light conditions for a survey measurement, we have to think about leaf angle. We need to think about the ratio of direct to diffuse light. What we mean by that is that if the sun is over here and our leaf is angled this way, there's not much direct light coming onto it. It's still receiving light, but it's all diffuse. It's not direct. And that means that the light level is lower. And we need to keep in mind that the quantum sensor measures light incident to a plane. So we may need to alter the angle of our sensor head to keep the leaf at the same light angle, especially if we are using a clear chamber like this one. If the leaf is normally growing at this angle and we put it into the chamber and we force it flat, then we have changed its light environment a lot. And so we need to keep that in mind. So choose a light level that is slightly lower than, but around the ambient light that you have, and be very aware of leaf angle and making sure that you monitor that. The next environmental parameter that we talk about when we talk about survey measurements is whether we do reference or sample CO2 control. And the decision for this is how much time you have and how sensitive your plant material is. The fastest way to do it is reference CO2 control. That's just a faster measurement because the chamber is smaller, and so we're able to reach equilibrium faster in that chamber than we do in the CO2 sample analyzer, which is larger, has a larger volume, and so it reaches equilibrium a little bit slower. If we want to measure reference CO2, however, especially if we're working with a crop that is very photosynthetically active, what can happen is that if we set the reference CO2 to ambient, the CO2 is taken up by the leaf, and now we are not actually at ambient, we are at ambient minus whatever the leaf took up. And that can affect the CO2 environment of the leaf. We talked a little bit about how in a closed gas exchange system, the leaf can respond to the changing CO2 level, and it can be a confounding factor in our measurements. So when we do a reference CO2 control for survey measurements, we often want to do the ambient CO2 concentration plus a delta CO2. So whatever the plant is likely to draw down in CO2, we give it back. So if ambient is 415 and our plant normally draws down 20 ppm, then we would set the reference to 435. So that it would still be around 415 in the chamber. If we control on sample, then we can just control at ambient CO2, 415, and then we are in good shape. So reference using ambient plus delta is faster, but if you have a plant that is sensitive to CO2, you may want to use sample and just accept that it's going to be a little bit slower for you to take your measurements. In terms of controlling temperature, you decide whether you are going to control temperature when it comes to a survey measurement. There are three main things to keep in mind. The most practical of those is battery life. The more we control temperature, the more battery life we have used. So if you're in a situation where you only have a few batteries and you need to take a lot of measurements, you may choose not to control temperature. But the challenge of not controlling temperature is that then there may be some influence on your leaf from either solar load and heating in a clear chamber, or LED load and heating in a chamber that provides its own light.